Let's look at the minimum requirement necessary to fire a Soma. First we'll bring in a neuron lab, start the neuron lab up, and bring in a step and a synapse. We'll connect an oscilloscope to the output of the synapse and connect the step to the input of the synapse. The step setup defaults to 10 picoamps, which produces 1.273 millivolts into the synapse. Do a right click, there we go. If you look at that on an oscilloscope, a second oscilloscope, left, left, you can barely see the that 1.2 millivolts coming in. Now we'll take a look at the help that I provided for the synapse and dendrites. And if you scroll down a bit, you'll see a drawing of a cylinder of a synapse and a dendrite. This is the synapse cylinder. Consider it the first dendritic cylinder in that synapse. You can see it has ESP, that's excitatory channels, and it has inhibitory channels. The green ones are excitatory, the red ones are inhibitory, and the rest of them are all leakage current. That leakage current is very important. It's not a bug in a human system, it's a feature, but later on that. Actually, there's many more excitatory channels than there are leakage inhibitory channels, about 3 to 1, but that's what they are. Now, every time you connect a step to a synapse, you're connecting to one of these excitatory channels. So if you set that back to now, now let's look down at the bottom where it talks about the minimum firing potential. Normally inputs to a synapse are about a 0.4 to 0.4 millivolts for one. So let's crank that down to 1 picoamp input and see what that produces. 1 picoamp produces 0.1 millivolts. So the way this works is the step gets the input impedance from the synapse, calculates the current that it would take to drive to reach 1 picoamp in this case, and it turns out it's 0.127 millivolts. Then it sets the output voltage right there to 0.127 millivolts. I set the step input back to 2 picoamps. Now what would it take to reach 35, or what would it take to reach 10 millivolt output at the synapse? Should take about 25 to 35 different steps. I can actually have that many steps, so I'll start attaching them. Left click. Left click. This is going to be a while, so I'll stop it and do that offline. So there's 9. That's the 10th one. 11th one. Let's see what we've got so far. Let me neaten this up a bit. Well, we're well over 10 millivolt input. We're about 27 now, but that's because all of these steps defaulted to a large number, 146 picoamps. Let me show you how to set those all at once so you don't have to fiddle with them. You go up here to setup, drag change, right click, change parts, and then marquee select with a right click, See selected parts. Now it gives you control over the whole thing. Let's say you put it down to 10 millivolt pulse width on all of them and run them in at 2 picoamps. So that should set them all. You can see the input voltage is now down to a smaller amount, about 0.8. So if we raise the pulse width up to 20, shut off this scope again. Now the input's about, so I have to raise it some more. Disable, setup, drag change, right, change parts, see selected parts. Okay, we're at 2. We could change that to 10 picoamps per set. Now we're well above it. Now we're at 11 millivolt input, 11 millivolts out of the Synapse into the Soma. So that should make it spike. Let me shut this off, the multiple select off. Right click, disable. Okay, now we've got it all going. Now if you look at the Soma output with an oscilloscope, it should be spiking. So you can see the you can connect 10 different steps to 10 different excitatory inputs and set them all to 10 picoamps, or you can set 100 of them to 1 picoamp and get the same effect. So you have to think when you're connecting steps to polarization points. And so one step at 300 would be the same as 3 at 100. Hope that made that clear. So now we've got one pulse input, and I'm going to connect it to 300 different excitatory inputs. And I'm going to do that by setting the current to 300. You can see that causes the Soma to start spiking. So there's a lot of adjustments you can make to get the same result, and you just have to play with them and get a balance between them to make sure you're getting what you expect out of it. Let's move on.